First of all, we'd like to introduce the eccentric anomalies. A single variable is required to determine the positions of a planet on the orbit. We could find out the orbit, but we'd like to find out the positions of the planet on the orbit. Yeah, all the position is possible if you just only write down the equations for the ellipse. But we'd like to determine the position of the planet on the orbit. So this position. How to determine this position? We'd like to introduce the two angles. First one is eccentric anomalies. So this is E is eccentric anomalies. How can we find out the eccentric anomaly? It's a little bit difficult to understand, but hopefully you understand. To introduce the eccentric anomalies, first of all, we need to consider the circles with a radius of A. So this orange circle has a radius of the A. This point A, this point A. So radius of A. So this length is also A. The ellipse is described. Actually, this ellipse is described as a compressed circles along the y-axis by a factor of the square root, this one. So if you compress the radius, not this one. If you compress the circle with the factors of square root 1 minus e squared, you could find this point. So this positions, coordinate of this point on the circle can be expressed using the E, eccentric anomalies. A cosine E. A sine E. This is the y coordinate. A sine E. A cosine E. As I explained, the elliptical orbit is compressed by the factor of these factors. So these positions, x coordinate doesn't change. A cosine E. Y coordinate is compressed by the factor of the square root A 1 minus e squared. A square root 1 minus e squared sine E. So this is expressions using the eccentric anomaly for the x coordinate and the y coordinate. Okay, eccentric. So now we'd like to introduce another angles of the we call the true anomaly. This is might be the much easier to understand. So in this case, to define the true anomalies, we consider the origins. Actually, the sun is located at origin here. Then r is a distance from the sun to the planet. This is the position of the planet. The true anomaly is defined angles formed by the radial vectors between the sun to the planet and the x-axis. X-axis. Right? Then this, if you consider these triangles, this is r sine f. This is r cosine f. And this is actually c. This is equal to the AE. So to describe this position on the x, y coordinate, x is AE plus r cosine f. This is the x coordinate. And the y coordinate is r sine f. This is the coordinate using the true anomalies. So f is a true anomaly. So we introduce the two angles. First one is the eccentric anomaly. The other one is a true anomaly. Two angles we use to determine the position of the planet on the orbit. Okay. Then practice 2. Use the two different expressions for the ellipse. So this is true anomaly. And then different expression for the this is the expression using the true anomaly. This is the expression for the ellipse. And then derive the following equations. This equation. So R and F should be related because we consider the planet is on the single orbit. So R and F should be related. That's the question. Then from this equation we are going to derive. So if you multiply a square times 1 over e square in the both sides, this becomes 1 over 1 minus e square times x square plus y square equal a squared 1 minus e square. Then you can substitute this x and y. Then it becomes 1 minus e square r cosine f plus ae square plus r sine f square equal a square 1 minus e square. Then we can expand 1 minus e square r square cosine square f plus a square e square plus 2ae r cosine f plus r square sine square f equal a square 1 minus e square. Then from this equation you can look at these terms to remove the cosine square f plus sine square f. It becomes equal 1. So this is r squared minus e square r square cosine square f plus 2ae 1 minus e square r cosine f so from these terms equal a square 1 minus e square squares from the distance to the distance. We combine these two terms. Then it becomes, if you combine these two terms, 1 minus e squared cosine square f r square plus 2ae 1 minus e squared r cosine f minus a squared 1 minus e square square equals 0. So this could be 1 plus e cosine f r minus a 1 minus e square 1 minus e cosine f r plus a 1 minus e square equals 0. So we have these equations. Then r is positive. 1 minus e cosine f is positive because e is really small numbers. A 1 minus e square is positive. So from this ones 1 minus e cosine f times r plus a 1 minus e square cannot become 0. This is positive. This corresponds to these terms. Positive. So we can divide it by these terms. Then this have to become 0. So it becomes 1 plus e cosine f r equal a 1 minus e squares. So r is expressed a 1 minus e squares over 1 plus e cosine f. Okay, this is the answer to the practice 2.